Welcome to another episode of the Stupid CS Guy. We are talking about the Dynamo paper. Like I said, the Dynamo paper is the basis of a lot of the current DBs that we use. For example, React, Voldemort, Cassandra. In this episode, we are going to go deeper into the Dynamo architecture. We will read through the paper, understand the concept of partitioning, how Dynamo makes the system more resilient to failures. So we'll start off with the paper again. And like I said, right, this is the table we are looking at. It's a summary of techniques used in Dynamo and their advantages. And the first technique that we are going to look at is the consistent hashing. This is how they solve partitioning. And why do they use consistent hashing? It is for incremental scalability. So we have three machines where we want to partition our data. Let's say something like a user ID. How do you partition the data? You can simply say, hey, user is an ID. What if we just do a mod 3? That means user ID of 1 goes to machine 1, user ID of 2 goes to machine 2, and user ID of 3 goes to machine 3. And user ID of 4 goes back to machine 1. Now all is fine and dandy here, but what if you add one more machine here? So no longer your scheme is no longer correct because now you will not be able to determine which machine it should go to because half of it is most of it the data is in machine 1, 2 and 3. Hence if you go with a modulo based approach, you would have to rebalance your data across all of these machines. To not do that, to make the scalability much easier, ideally what you want is when machine gets added, you do not have to rebalance the data across all the disks. Instead, only a subset of disks get affected. And that is where consistent hashing comes in. The idea of this video is not to talk about consistent hashing. I'll provide links to good videos where they talk about consistent hashing in the description. So do look at that. I'll give a very brief overview so that you have what it needs to understand the paper. In consistent hashing, instead of you doing a mod, you have a key space. Maybe this key space is 1 to 1000. So these blue boxes are your database hosts and this is your key space. So you have 0 to 1000. What this basically means is from 0 to whatever this point in the number is, let's say 125, all of this data will sit in this database hosts called, let's say, D1. From 125 to 375, all of the data will sit in D2. And then from here to here, all of this data would sit in D3. So the idea is you'll hash your data to one of these numbers. So if you have a user ID of 0 to 500 or 0 to 1000 or whatever it is, you'll hash to one of these numbers, and when and then it from there it will start going clockwise direction, and it will keep going clockwise till it finds a machine. So here it will be D4. Now what happens if you remove this machine? The only thing that you would need to rebalance is the data in this machine, which is of course, so you'll rebalance, you put the all of the data in the D2. If you add one more machines here, the rebalancing will only happen between D1 and D2. If you put another database host here, the rebalancing only needs to happen between D2 and D1.5. The rest can, continue serving traffic. That is the concept of consistent hashing. What consistent hashing says is that whenever you add another node to a system, it should be fairly easy. You do not have to rebalance all of your data, which can be fairly large. And this is exactly what Dynamo based systems do. So let's try and now go through the paper. So Dynamo is targeted mainly at applications that need an always writable data store where no updates are rejected due to failures or concurrent writes. This is an AP system. Just look at my previous video if you don't remember what an AP system is. This is a system that prioritizes availability over consistency. Dynamo is built for latency sensitive applications that require at least 99.9% of read and write operations to be performed within a few hundred milliseconds. So Dynamo is built for scale. It needs things to be really fast and needs to be always on. First, of course, we spoke about the partitioning algorithm, so let's go over the key parts. Dynamo's partitioning scheme relies on consistent hashing to distribute load across multiple storage hosts. Like I said, in consistent hashing, the output range of a hash function is treated as a circular space or ring. The largest hash value wraps around to the smallest hash value. You can see 1000 wraps around to 0. Each node in the system is assigned a random value within this space, which represents its position in the ring. Each data item identified by a key is assigned to a node. By hashing the data item's key to yield its position on the ring and then walking the ring clockwise to find the first node. So, like I said, if you have a hash which comes to 770, so we'll start walking in clockwise and find D4, and that is where we will store. So this each node becomes responsible for the region in the ring between it and its predecessor node. So the basic consistent hashing algorithm presents some challenges. Because of the random positioning of each node on the ring, it leads to non-uniform data because you could have data which is hashing to 0 to 250 key space in the ring. In that case, only D1 will be taking all of your load, while D2, D3, D4 might not be taking much of the load. To fix this, Dynamo uses a variant of consistent hashing. So instead of mapping a node to a single point in the circle, each node gets assigned to multiple points in the ring. So think about it, D1, which is the machine, is not only responsible for 0 to 250 key space, it is responsible for maybe 300 to 350, 400 to 450, and all of that. So each node gets assigned to multiple points in the ring. To this end, Dynamo uses this concept of virtual nodes. So these nodes are not actually real machines. These nodes map to the same machine. So in essentially what Dynamo is saying that, so let's say we introduce one more here and let's call this D5. So this is also another host. So what might happen to Dynamo is your D5, D4, and D2 might all map to the same storage host. So let's call this just D. And so D4 also maps to D, D2 also maps to D, and maybe D1 maps to D. So even though D4, D2, and D1 looks to be like, separate nodes in a consistent hash ring, but they're really virtual nodes and all of them map to the same physical machine. Now, a virtual node looks like a single node in the system, but each node can be responsible for more than one virtual node. Now, there are a couple of benefits of virtual nodes. If a node becomes unavailable, the load handled by this node is evenly dispersed across the remaining available nodes. In the classical model, just forget for now that these are virtual nodes. If D1 would go for a toss, then all traffic for D1 would go to D2, right? And D2 might not be able to handle it. But since these are virtual nodes and these virtual nodes are all closer to each other, so if D1 goes for a toss, so this amount of traffic D1 handles is fairly small now. It is no longer 0 to 250, it will be probably 0 to 50 each. And that slight increase could be handled by those machines. The number of virtual nodes, and this is the most important one, that a node is responsible can be decided based on its capacity, accounting for heterogeneity in the physical infrastructure. In essence, what it means is that you can have a 10 GB machine having 10 virtual nodes and 100 GB machine having hundreds of virtual nodes. This allows the system or the individual storage host to be completely heterogeneous to take advantage of the advances in computer technology. Now we will talk about replication. To achieve high availability and durability, of course, you would need your data to be replicated into multiple systems. It is simply not possible for data to be present in one storage host. You would expect the storage host to be always on for the entire time. So hence, what Dynamo does is Dynamo replicates its data on multiple hosts. So each data item is replicated at n hosts, where n is a parameter configured per instance, and we'll talk about n a lot. Each key k is assigned to a coordinator node. So what's a coordinator node? A coordinator is in charge of the replication of the data items that fall within its range. In addition to locally storing each key within its range, the coordinator replicates these keys at the n-1 clockwise successor nodes in the ring, which means that if a data is getting stored at D1, it will also get stored in n-1 successor nodes, which means let's say n is 3. So if a key lands up, let's say key is which is 120, lands up in D1, it will also get replicated in D2 and it will get replicated in D5. And that's exactly what it talks about in the figure. So let's just go and look at the figure once. So your key comes here. Your B takes responsibility of that key, and then it will also get stored in C, D, and whatever that n value is. The list of nodes that is responsible for storing a particular key is called the preference list. If you need to look for a key, you need to go and understand that preference list. The item on the top of the preference list is typically the coordinated node. And the coordinated node could be any node. It's not like some special node. It could be any node. It is just that the item in the top of the list is generally the coordinated node. The system is designed, as will be explained, so that every node in the system can determine which node should be in the list for any particular key. And we'll talk about it. So there is no central system which is keeping track of, hey, this key is in these machines. Everybody knows it. Everybody can handle that request. And we'll talk about the peer-to-peer aspect later. These nodes can go down. So to account for node failures, preference list contains more than n nodes. And of course, note that with the use of virtual nodes, it is possible that the first n successor positions for a particular key may be owned by less than n distinct physical nodes. Because of course, these are virtual nodes. So you're walking the ring and it could be actually 2 or 3 machines. Even though your n is maybe 10, it's maybe actually going and sitting in 3 machines. Now, Dynamo is intelligent there. To address this, the preference list for a key is constructed by skipping positions in the ring to ensure the list contains only distinct physical nodes. Now, a lot of databases like Cassandra go even further where they make sure that the data is replicated in storage hosts which are sitting in a separate rack in a data center, so that even if entire rack goes off, your data is still safe. So that is how the redundancy and replication is being built in. Of course, now since you have data sitting at different nodes, what would happen? Remember our master model? Of course, you would have conflicts. How do you deal with conflicts? Well, that's for the next section.